Hello there, this is Mr. John Wesly, Assistant Professor of BCA Department from AJK College of Arts and Science. Today I'll explain about the topics on Introduction to Algorithms and Analyzing Algorithms. So let's get on to the topic. The word algorithms come from the name of Persian author Abu Ja'far Muhammad al-Musa, who wrote a textbook on mathematics. The word algorithm has come to refer to a method to solve a problem. So first we'll see about what is the definition of an algorithm. So what is an algorithm? An algorithm is a finite set of instructions that, if followed, accomplishes a performed task. In simple terms, it is a step-by-step procedure for solving a given problem. So what is an algorithmic strategy? The way of defining an algorithm is called an algorithmic strategy. It can be called recursively until the number of required iteration or goal is reached. An algorithm can be implemented in any suitable programming language. Next, we want to see what is the characteristics of an algorithm. All algorithms must satisfy the following criteria, and an algorithm should have the following characteristics. First, we'll see what is the input. It is very important one that without an input, an algorithm cannot be performed. So, zero or more quantities are externally supplied. Next one is the output. At least one quantity is produced. So, if there is an input, surely there will be an output. The next one is the definiteness. Each instruction is clear and unambiguous. It should not confuse. The next one is the definiteness of the algorithm is all operations should be well defined. For example, operations involving the division by zero or taking the square root for negative number are unacceptable. The next one is the finiteness. If we trace out the instruction of an algorithm, then for all cases, the algorithm terminates after a finite number of steps. It is not an infinite one. The last one is effectiveness. Each and every instruction must be very basic so that it can be carried out in principle by a person using only a pencil and a paper. It is not enough that each operation should be definite. And at last, the correctness, which is the algorithm should be an error-free. So the next characteristic is the effectiveness. Every instruction must be very basic so that it can be carried out in principle by a person using only a pencil and a paper. It is not enough that each operation should be definite. So the next one is the correctness. The algorithm should be an error-free. So next one is the simplicity. Each and every algorithm should be very easy to implement. It should be very easy that anyone can be able to written with a pencil and a paper. The next one is unambiguous. Algorithms should be clear and unambiguous. Each of its steps and their inputs or outputs should be clear and must be lead to only one meaning. The next one is the feasibility. It should be feasible with the available resources. It should be achievable. There is no use of writing an algorithm for an impossible task. The next one, algorithm should be a portable one. An algorithm should be a generic, independent of any programming language or an operating system, able to handle all range of inputs. The next one is independent. An algorithm should have a step-by-step directions which should be dependent of any programming code. The next one, the main topic we're going to discuss about is writing an algorithm. Algorithms are generic and not limited to a computer alone. It can be used in various real-time activities also. Knowingly or unknowingly, we perform many algorithms in our day-to-day life, such as packing our books in a school bag, finding a shortest path to search a place, or scheduling a day-to-day activities or preparation for examination, etc. As we know that all programming languages share basic code in constructs like conditions and iterations can be used to write an algorithm. A typical algorithm is in the following, which includes input, process, and the output. The typical algorithm, for example, consider the example of a coffee preparation. To make a coffee, we need to have the following ingredients: water, milk, coffee, powder, and sugar. These ingredients are the inputs of an algorithm. Preparing a cup of coffee is called a process. The output of a process is the coffee. The procedure for preparing a coffee is as follows. The first step is take a bowl with the coffee powder. The second step, boil the water and pour it into the bowl. The third step, filter it. The fourth step, boil the milk. The fifth step, mix sugar and filtered coffee along with the boiled milk. And at last, pour the coffee into the cup to serve. Thus, the coffee is prepared. This kind of procedure can be represented using an algorithm. Thus, an algorithm consists of step-by-step instructions that are required to accomplish a task and helps the programmer to develop a program. So, next topic we'll discuss about is what is the difference between an algorithm and a program. Algorithm is different and the program is also different. In slight way, it is a combined one. So, we're gonna discuss about the difference between an algorithm and the program. So first, algorithm helps to solve a given problem logically, and it can be contrasted with the program. Whereas a program is an expression of an algorithm in a programming language. Algorithm can be categorized based on their implementation methods, design techniques, etc. Whereas in programs, algorithm can be implemented by structured or object-oriented programming approach. And in algorithm, there is no specific rules for algorithm in writing, but some guidelines should be followed. Whereas in program, should be written for a selected language with a specific syntax. In algorithm, resembles a pseudocode which can be implemented by in any language, but in program, is more specific to a programming language. The next topic we discuss about is what is the analysis of an algorithm. Compute resources are limited. Efficiency of algorithm is defined by the utilization of time and space complexity. Analysis of an algorithm usually deals with the running and the execution time of various operations involved. The running time of an operation is calculated as how many programming language instructions executed per operation. Analysis of algorithm and performance evaluation can be divided into two different phases. The first phase is a priori estimates and second phase is posteriori testing. The priori estimates is the theoretical performance of analysis of an algorithm. Efficiency of an algorithm is measured by assuming the external factors. The next is the posterior testing. This is called the performance measurement. In analysis, actual statistics like running time and required for an algorithm and executions are being collected. In simple words, a priori estimates is a theoretical one, whereas in posterior theoretical testing is a practical one. The next one is the complexity of an algorithm. Suppose A is an algorithm and N is the size of an input data. The time and space used by algorithm A are the two main factors which decide the factor efficiency of A. The time factor is measured by counting the number of key operations like comparisons in the sorting algorithm. The next is space factor. The space factor is measured by the maximum memory space required by the algorithm. So here we're going to discuss about the difference between the time factor and the space factor. The time factor is the measurement of time that an algorithm takes to complete its execution, and the space is measured by the maximum memory space required by an algorithm to perform its operation. The next one is the time complexity. Time complexity of an algorithm is given by the number of steps taken by the algorithm to complete the process. And the second one is the space complexity. The space complexity of an algorithm is the amount of memory required to run its completion. The next one is the efficiency of an algorithm. Computer resources are limited that should be utilized efficiently. The efficiency of an algorithm is defined as the number of computational resources used by an algorithm. An algorithm must be analyzed to determine its resource usage. The efficiency of an algorithm can be measured based on the usage of different resources. For maximum efficiency of an algorithm, we wish to minimize resource usage. As I already told, algorithm must have input, output, and should satisfy the following characteristics such as definiteness, correctness, and effectiveness. Data are maintained and manipulated effectively through the data structures. Algorithms can be developed to store, manipulate, and retrieve data from such data structures. Examples for data structures are arrays, structures, lists, tuples, dictionary, etc., which we will discuss in the next class. Thank you. Have a good day.